Good morning, sir. Our topic is gender classification using iris texture. My name is Akash Vishkarma, roll number CS21B1066, and my teammate name is Rashmi Ranjan Prem, roll number CS21B1051. The main highlight of our research is that investigating the impact of a fusion mark on gender classification accuracy and proposing a method to isolate gender-specific information exclusively from iris texture. The table of content include introduction part where we will introduce the main overview of our research, then method overview where we explain the methodology, dataset description where we introduce we will tell about the dataset which we used, and then about the result of the mass pairing effect, pair penalization, pair removal, and classification result. And after all that, we will go for conclusion part and future works. In iris biometrics, oxygen marks are vital as they delineate the region of the iris that are hidden or occluded by eyelids, eyelashes, or other obstruction. Oxygen marks play a critical role in iris recognition system by ensuring that only the visible iris texture is considered for the identification or verification. However, if these marks inadvertently contain gender-related features or cues, they can introduce bias into gender classification algorithm. Our main objective is, given the potential bias introduced by oxidation mask, it is crucial to understand and mitigate their impact to ensure fair and accurate gender classification based solely on iris texture. We propose pairing occlusion mask based on gender to eliminate gender-related cues. This involves grouping mask into male-female pairs. And this involves grouping mass into male-female pair and generating paired marks by performing logical operational errors. In our research, we aim to address the potential bias introduced by oxygen mass and gender classification based on iris flash. Oxygen which are used to segment the iris region in images may inadvertently contain gender-related information due to factors such as makeup, segmentation errors, or differences in sensors technology. To mitigate this bias, we propose a novel method of pairing oxygen marks by gender. The methodology involved a grouping of oxygen marks into male-female pair by generating paired marks by performing logical operation on each pair. This process ensured both iris images in a pair had identical oxygen marks, effectively removing any gender-related cues present in the mass. By equalizing the distribution of oxygen marks between genders, we aim to focus the gender classification solely on the iris texture independently on any bias introduced by mass. We evaluated the effectiveness of our method using two data sets, gender from IRIS GFI dataset and ND cross sensor IS 2013 CSI dataset. The GFI dataset is comprised of 3000 iris images from 1500 subjects, while the CSI data size included 29,986 images from 676 subjects. We conducted classification experiment using various classification types, including VGG full and VGG plus classified with and without paired mass on both datasets. Before applying paired marks, the classification accuracy varied across different tests and datasets. On GFI dataset, the VGG full test yield an average accuracy of 62.13% without the paired mask, while on the CSI dataset, the average accuracy was 59.90%. However, after applying paired mask, the average accuracy decreased across the all test and data. For example, the G5 dataset, the average accuracy decreased to 61.69%. For the VGG full and test and on the CSI it decreased to 56.54%. This reduction in accuracy significant impact on paired mask. By removing gender-related cues in the fusion mark, the paired mask alter the classification, leading to a decrease in accuracy. While this decrease may initially seem concerning, It's essential to recognize that it reflects a more accurate assessment of gender information present solely in iris structure, excluding any bias introduced by exclusion mask. The observed reduction in accuracy underscores the importance of understanding and mitigating the impact of exclusion mask on gender classification accuracy. Although the use of paired mask may lead to decrease in accuracy, it provides a more unbiased, accurate representation of gender involved in iris structure, ultimately advancing and the reliability and integrity of iris-based gender classification method. Through our approach, we aim to demonstrate the importance of understanding and mitigating the impact of oxygen by on gender classification accuracy. By pairing oxygen mass by gender, we sought to provide a more accurate, unbiased assessment of gender information present in iris structure, thereby advancing the field of iris-based gender classification. Future research direction based on the finding include quantifying the information lost during mass pairing, which could provide insight into trade-off involved in the process, rationally utilizing the newer deep learning technique for uh, improved segmentation would enhance accuracy while reducing the need for manual mass correction. These advancement would streamline the pairing process of and potentially yield more accurate gender classification. Further, the investigation into impact of makeup in gender classification and development of methodologies to recover significant information lost during pairing without reintroducing biases are also potential areas for exploration. The research revealed that the occlusion mask significantly influenced gender classification accuracy, emphasizing the importance of focusing exclusively on iris structure for accurate result. Pairing oxygen mask by gender classification um, by gender classification uh, focusing exclusively on iris structure and accurate result. Pairing oxygen mask by gender equalize their distribution, shedding light on the impact of these mask classification. Understanding and mitigating this impact are crucial and unbiased diametric array. The study of underscore and necessity of quantifying information loss during mask pairing and exploring newer deep learning technique for improved segmentation. Ultimately, prioritizing higher structure analysis can enhance the reliability of gender classification in biometric system.